Hello students, welcome back to lecture class 2 on milling machine chapter 2 of the 5th module, the elements of mechanical engineering course. In this class we are going to discuss mainly about the operations, milling operations, what all the operations we can do in the milling machine tool. So plain or slab milling, end milling, slot milling, angular milling, form milling, straddle milling, gang milling. So all these operations we can do, and more than this also we can do. So these are operations as per the syllabus in our course. First we'll discuss about the plane milling. What is the plane milling? So you can see here play workpiece. So this is the workpiece and this is a milling cutter is plane. So top surface of the workpiece we have to do the milling operation. That means we have to level this. The surface maybe sometimes up and downs will be there. All the surface we have to make it a level. The entire workpiece surface we have to make it a level. So at the time this we have to fix the milling cutter. Milling cutter means a multi-point cutter. Cutting points will be multi-point milling cutter. That we have to fix it in the R bar, horizontal direction. See the R bar position horizontal. Okay, it is not vertical. Horizontal R bar. So we have to fix the milling cutter in this horizontal R bar, and when it is rotated, okay, the R bar is rotated. Parallelly, the milling cutter is also rotates, and we can move the workpiece from one end to the another end. So this is a plain milling cutter with a helical teeth. So it is a plain milling cutter, helical teeth is used. So the process is carried out on horizontal milling machine with a cutter having a straight or helical. It may be a straight one or it may be a helical one formed on the periphery of the cylindrical surface. A plain smooth surface can be moved, produced with this process. Helical tooth cutter removes greater amount of material than the straight one. Helical teeth are, helical means the crossed, the teeth are of the cross. This is, see the crossed teeth. Okay, so this cutter removes more amount of material, greater amount of material, and produces smooth surface finish when compared to the straight tooth cutter. So generally straight tooth cutter will not remove that much of material, and also you will not get the smooth surface. So helical tooth cutter, helical tooth means what? All the cutting points are the helical shape. Okay, cross, that is called helical. So this removes a lot of material, at the same time smooth surface. You will get the workpiece surface will be smooth surface. Okay, this is a plain milling operation. Okay, so to sum up again, so workpiece, this is a arbor horizontal. Okay, this we have to perform in the horizontal milling machine. Okay, the plain milling cutter, it is mounted on the arbor. So as the arbor rotates, the plain milling cutter also rotates. We have to give the feed like this, and all workpiece surface will be leveled. It's a plain milling. Is also called as a slab milling. Next comes about the end milling. So end milling, you see here, end milling cutter. Okay, it is a producing flat surfaces, profiles, slots, grooves. So it's a some sort of groove you can see here, or finishing edges of the workpiece. You can finish the edges also. This is the edge. You wanted to finish this. So here some surface is not level. Then you can use this. You can finish this edge, entire edge. You can finish it. Carried out for producing a flat surfaces, profiles, slots, grooves, or finishing the edges of the workpiece by means of a tool called end mill cutter. So this is different, and previous one what we have seen, that is different. Plain milling cutter is different. End milling cutter is a different. End mill or end milling cutter. Okay. So the cutter usually rotates on an axis perpendicular to the work surface. So the workpiece perpendicular. Earlier you have seen horizontal, parallel to the work surface. Now it is perpendicular to the work surface. And it can be tilted to the machined tapered surface also. It can be tilted to machined tapered surface. End mills are also available with hemispherical ends, ball nose, for machining curved surface in metallic dies or molds. So this is about the end milling. Next is slot milling. So slot milling, you can see here, you can make a slots here, small throat width, you can make this. So slot milling is a machining process for producing a slots like as T slots, okay, or plain slots or dovetail slots in the work table fixtures and other work holding devices. The operation may be performed using either end milling cutter or T-slot cutter or dovetail cutter or side milling cutter. Any cutter you can use it. So this type of cutter selected depends upon the shape of the slot to be produced. What type of shape of the slot you want. Depending upon that you have to select. So in this we have seen two separate milling cutters are required for milling T-slots. Two separate milling cutters are required. Why I will tell you. So two separate milling cutters are required for milling T-slots. One is a plain cutter, side cutter or end milling cutter is used to cut a throat. First you have to make a throat. Okay. Next is open slot, starting from one end of the workpiece. Next, you have to insert a T-slot here. A T-slot milling cutter is then used to cut the head space to desired dimension. So in that way, we have to make a T-slot in the slot milling. So slot milling means we have to make some sort of slots, some T-slots. Yeah, any shapes, anything you can make using this slot milling operation. Slot means what? Slot means some sort of provision is called as a slot. Okay, inside the workpiece. These things we cannot make with the plain milling or end milling. You have to use some special devices, some special cutters to make this slot milling operation. Next comes angular milling. That is you want to cut some angles. You are using angular cutter here. So angular milling is a machining process for producing all types of angular cuts like V cuts, V notches, grooves, serrations. Okay, any type of grooves, etc. We can use angular milling. Some sort of V groove here. The V groove. Okay, so, some type of cuts, angular cuts, we can make it. Okay. Next, the cutter is called as angle milling cutter. This name is called as angle milling cutter or angle cutter. Okay. So it has either single angle type having a teeth on its conical surface that can produce an angle or a chamfer. Single angle cutters are there here. Single angle is a double angle cutters. Okay, single angle cutter and double angle. Only one side angles are there and this is a double side angle cutters are there. So the cutter, double side angle cutter is a conical surface that can produce double angle cuts. Okay, angular angle cutters may also be used to produce dovetail slots. Dovetail slots we can produce. So this is about the angular cutting. Next comes the form milling. So form milling is a machining process carried out for producing curved profiles with a variety of shapes like concave, convex, splines. Okay, any shapes. This is what type? So concave shape. Okay, this is a concave. So this is what convex. Convex shape you can produce. Some grooves you can produce. Understand? Convex, concave shapes. Some splines you can produce. Splines. Okay, splines will be in some shapes, some curved shapes. So splines. Okay, some profiles, some sort of profiles you can produce with the help of form milling, using a form milling cutter. So the tool is called as form mill cutter. Next is straddle milling. So straddle milling is a machining process in which a pair of milling cutters. So in this pair of milling cutters, you can see it, one milling cutter is there and one more milling cutter is there. The differences between so their distance is maintained by the spacer. Okay, spacer is there. So both milling cutters, it will cut this portion. It will mill this portion. It will mill this portion. Okay. So this portion is not milled. Okay, this portion is not milled. So this straddle milling cutter consists of pair of milling cutters. Only two. Okay, pair of milling cutters used for machining two parallel vertical surfaces. So this is a workpiece. So this edge you have to mill it. This edge you have to mill it parallelly so that you can save the time. You can do with end milling cutter also. So the same thing can be done with the end milling cutter. End milling cutter what will do? So the end milling cutter, it will just make the only one surface one time at a same time. Okay, but in this case, straddle milling, two edges of the workpiece are milled or machined parallelly with the help of a straddle mill cutter. Okay, the side milling cutters can have a cutting edge on one or both the sides as well as periphery. So it is accomplished by mounting two side milling cutters on the same arbor. So this is the arbor, same arbor. same arbor, so that different profiles required on the workpiece can be machined simultaneously in a single pass. It will saves the time. Okay, saves the time also. So that this next is the this one, a straddle milling is accomplished mounting two slide milling cutters on the same arbor set apart at an exact spacing with the help of spacers, washers, and shims. So the distance between the cutting teeth of each cutter is exactly equal to the width of the workpiece area being machined. Okay, so this is about the straddle milling. Next, last one is called a gang milling operation. So gang milling, there is more than two. Okay, more than two you can fix. Milling cutters can be fixed. Understand, more than milling cutters. So here what is the, you see here, entire surface, entire surface, entire surface is being machined with the help of plane cutter. So this is a slab side cutter, slide slab cutter. Totally it is being the machine, and milling cutters are there here. So gang milling is a machining process in which two or more cutters are mounted on the same arbor so that different profiles required on the workpiece can be machined simultaneously single pass. Simultaneously in a single pass. Okay. So all the cutters used may be of the same type or different types depending upon the type of surface being machined. So this is side cutter. This is also a side cutter. This is a plane cutter. See, so many, how many cutters are there? One type. Second type. This is third. So this one and this one are same because side cutter or say slab cutter both are same. This is a plane cutter. So the this entire works from this end to this end of the workpiece, it is being machined continuously. So it saves a lot of time. It saves the lot of time. Simultaneously you are machining, you are planing the, you are milling the entire surface workpiece simultaneously with the help of first, second, third. That is why we call it gang milling. Gang means what? Group. Correct? You know that. Gang means what? It is a group. So group of milling cutters are machining the workpiece is called as a gang milling. It saves a lot of time, and it okay. So this completes the milling operations. This completes the chapter of milling. So chapter 2 in the module 5 we have completed. The next will be chapter 3, the advanced manufacturing techniques. In the fifth module, that is the last chapter. In that last chapter we have CNC machines and robotics that we will discuss. Okay, thank you for watching the video.